Hello students, welcome to my official YouTube channel Mathematics on Levels, and today we are discussing the topic sequences and series. So in sequences and series I'll be making 4 to 5 videos of the questions where the majority of the students get stuck. So this is the first video of the sequences and series. So the first video is based on the formula derivation and its code series, means the fundamental proof where majority of the students get stuck. So let's directly come to the topic. The first major important derivation which is there in 9MA0 is Sn derivation, means sum of n terms derivation for arithmetic progression series. So we all know that means what is arithmetic progression. So if I say that if we are writing sum of n terms, so we can say that it will be equals to a1 plus of d, means this is our second term. Similarly, this could be written like third term could be written like a1 plus of 2d plus of, this will go till an. This will be the last term, means all the terms get added, then only we will be able to find the sum of n terms. Now if I reverse this series, for example, I'll write this series again from backward direction. So if I write the series from backward direction, it means an plus of, now the second last term in the series will be an negative of d. It's because the d is the common difference by which the series is getting getting added, means that consecutive term are getting added with the common difference d. Similarly, the third last term will be an negative of 2d plus of, it will go till the first term. So in the first sum of the n series, what I did, I have just taken the sum of all the terms from a1 to an. In the second term, what I did, in the second summation, what I did, I have started the series from the backward direction, means both are the sum. Okay, now if I say, what if I add them, both of the equations, if we are adding them, then what we'll get, means adding these both series, what we'll get. So on the left hand side, it is very easy for us, it will be 2Sn, and in the right hand side you can see, students, that the terms will get start to cancel out. For example, plus d will get cancelled out with negative d, plus 2d will get cancelled out with negative 2d. So what we'll left out with, I'll write it for you. Yeah, so the first term will be a1 plus of an. Similarly, the second term will also be a1 plus of an. Now similarly, every d terms will get cancelled, and the last term remaining will be a1 plus of an. So how many times this a1 plus of an gets repeated is n times. Okay, this a1 plus of an, you need to think collectively for a1 plus of an. So this, how many times this is getting repeated? So it is getting repeated n times, students. So from here we can say 2 times of Sn is equals to n times of a1 plus of an. Okay, now if I transpose 2 to the right hand side, we'll get n by 2 a1 plus of an. Okay, now this could be written as n by 2 a1 plus of an. We know an is the last term of an arithmetic progression series, arithmetic progression. So an could be written as a1 plus of n negative 1 cross of d. This is the general formula of an. So what we'll get from here, n by 2 in the bracket, we are left out with the term 2a1 plus of n negative of 1 by d cross d, sorry. So the mean value will be, students, Sn is equals to n by 2 in bracket 2a plus of n negative of 1 cross of d. Okay, this is also the sum of n series, n terms of the arithmetic series, and also this is also an sum of n terms of an arithmetic series. This is here, this is here. Okay, So this is the proof of a student sum of n terms of arithmetic terms in arithmetic series. Now let's move to the another derivation, student. Yes, the sum of n terms derivation for geometric series, students. Okay, so what I will do, I'll write it sum of n terms of geometric series. So we know that the first term of the geometric series is represented by A. Similarly, the second term is represented by AR. Third term will be represented by AR square plus of dot dot dot. It will go till AR negative n raised to the power 1, negative 1. Means this is the last term, AR raised to the power n negative 1. This is the last term. And we have added these terms to get the sum of n terms. Okay. Now what I'll do, student, I will multiply R in whole series. Okay, I will multiply R in whole series. So if I multiply R in whole series, so we can say that we'll get AR, means the first term will be AR. Similarly, for this series, the second term will be AR square. Okay, don't get confused between the first and second series. For second series, the second term will be AR square. For the first series, the third term will be AR square. Similarly, if we go on doing like this, we'll get second last term as AR negative 1 plus of the last term of this series will be AR raised to the power n. Okay, we have multiplied R to this the series written above. So let's consider this as the first equation and this as a second equation. So what I need to do, I'll subtract equation number 1 from equation number 2. Equation number 1 from equation number 2. So on doing this subtraction, so we can see here means we are subtracting equation number 2 and equation number 1. So from equation 2 we are subtracting equation 1. So on the left hand side we'll get RSN negative of Sn. Similarly on the right hand side we'll get AR raised to the power n negative of A. Okay, because all the terms get cancelled here. So AR power n negative of A. So what we'll get from here, we are taking Sn common, so we'll get R negative 1 equals to A common here, we'll get Rn raised to the power n negative 1. So from here we can say Sn is equals to A R power n negative 1 upon R negative 1. Okay, so this is the sum of n terms of a geometrical series, student. Okay, this is the sum of the n terms of a geometrical series when R is greater than 1. Okay, similarly we can calculate when R is less than 1, what we'll get with Sn equals to A 1 minus of R raised to the power n upon 1 negative R. This is the for when R is less than 1. Okay, so if we see for this series only, for this sum, if I say that R is less than 1 when R is less than 1. Okay, and this n term we are calculating now for the infinity terms, so S infinity. So we know that A1 negative of R raised to the power n upon 1 negative of R, where R is less than 1. So for infinity terms, students, we know that if a number is between 0 to 1, so its power is n, means it is getting multiplied n times. So this will be here infinity times. So if R is less than 1, it lies between 0 to 1. So what will be the value of this particular term? It will be 0. So you will get here, this term get cancelled. So we'll get A by 1 minus of R. So this is the S infinity, means the sum of infinity of a geometrical progression series. So where means the terms are infinite. We don't know whether it is means we don't have any finite value at the end. So this is how we used to get for infinite, the sum of infinite series. Okay, for geometrical progression. Okay, this we need to see. Now let's move ahead. Yeah, in the question student, they have mentioned in a geometrical series the common ratio is r and sum to n terms is Sn. Given S infinity is equals to 8 by 7 cross of S6, show that r is equals to plus minus 1 by root k, where k is an integer to be found. Okay, so they have given a certain value, that is S infinity is equals to 8 by 7 cross of S6. So S infinity we have already calculated, that is a by 1 minus of r. Okay, in the previous slide only I have told you. So 8 by 7. Now for sum of 6 term, what is the formula? We can see here if you want. See, this is the formula for calculating the sum of geometrical series for 6 terms they have asked for. So we'll replace n with 6 here. So we'll get here a 1 negative of r power 6 upon 1 negative of r. Okay, this is what we are getting. So we can see here that this term and this term is common at both the sides, so we'll get cancelled. It means that this will get cancelled out. Similarly, a is common on both the sides, so it will also get cancelled. What we are left out with here, 8 by 7 is on the right hand side, so it will get into cross multiplication with 1, so it will be 7 by 8. On the left hand side, we'll get 1 minus of r power 6. On further calculating, student will get r power 6 equals to 1 negative of 7 by 8. Okay, I have transposed their sides, means r power 6 to the left hand side, 7 by 8 to the right hand side. So what we'll left out with, r power 6 equals to, if we take the LCM here, so we'll get 1 by 8. So we can say r is equals to 6th root of 1 by 8. 6th root of 1 by 8. So we can say here that k is an integer to be found. So that r is equals to plus minus of 1 by root k. Since this is an even number, this is the 6th root, so obviously it will be a plus minus 1 by root k. So we have already find the values, student. Plus minus, we will write it here. So it is 6th root of 8. Okay, so this is our solution for this question. This series is a convergence series. Means we are having a, means this series will get, means this series will get completed at one point. So because they have already told that we need to find the S infinity, means it is getting converging. So this series is a convergent series. So this is our values, student. It gets we get it as plus negative plus minus 1 by 6th root of 8. So we have found the integer as well. So now let's move to the next question, student. Yeah, large scale arithmetic summation. In an arithmetic series, the first term is 16, the 21st term is 24. Find the common difference of the series, hence find the sum of the first 500 terms of the series. So in this arithmetic series, wait a sec. Yeah, in this arithmetic series, the first term is 16. Okay, and the 21st term is 21st term is 24. Okay? So we know that the sum of the n terms, the nth term of the arithmetic progression is given by an is equals to a plus of n negative of 1 cross of d. Okay, for 21st term it will be a21 equals to a plus of 21 negative 1 cross of d. So yes, so 21, so 21st term is 24, so we'll write it here as a 24. A they have given in the question, the first term is as 16, so we'll write it as 16. Now this will be 20d. Okay, so if we calculate it further, what we'll get, we'll transpose 16 to the left hand side, so we'll get 8 equals to 20d. So from here we can say that d is equals to 8 by 20. which on further calculating will get 2 by 5. Okay, 2 by 5 is the common difference of the series. So we can mark this as a common difference which they have asked in part 1. Now in the second part they have asked find the sum of the first 500 term of the series. So we have already calculated, student, the first 500 terms, means the sum of nth term of the arithmetic progression arithmetic series. So it will be Sn is equals to n by 2. We have two formula with us, students: 2a plus of n negative of 1 cross of d. This we know. So for 500 it will be S 500 equals to 500 by 2. 2a is 16 here, so we'll replace a with 16, plus of n is 500, so it will be 499, because 500 negative 1 will be 499. D we have calculated, that is 2 by 5. Okay, so this is the sum of the, yeah, so this is the sum of the 500 terms of this series. We can calculate it from here. So we'll get 499 cross of 2 by 5. Okay, so if we want to calculate it, we'll calculate it here. So we'll get 499 cross of 2 by 5, that is equals to 199.6. So this term will be 199.6 plus of 32, that is 231 cross of 250. So we are getting total value, student, as 57900. So this is the sum of 500 terms of this series. Okay, students. So this is how we need to calculate it. So this was the first part of our sequences and series. Now we'll move to the second part, and we'll be discussing more about this concepts and more typical problems where the students get stuck, which and this part, this whole chapter will be covered in 4 to 5 lectures. So that's it, students. Thank you.